All right, hi everybody. For our e-learning day today, we're going to be starting chapter 4. We're going to be looking at 4.1, which is about congruent figures. So we've dealt with a lot of congruent measurements like congruent segments and congruent angles, and that means that the segments or angles have the same measure. Figures are a similar concept, but there's a little bit of added information that we need to know. So our definition for congruent figures is that if two figures are congruent, then they have the same size and shape. In order for two figures to have the same size and shape, corresponding sides and corresponding angles must be congruent. By corresponding, I mean the ones that would like match on either figure. So the ones that would associate with each other. Think like our corresponding angle postulate. Those were angles that were in the same position. That's what that would mean in this situation. When you name congruent figures, you must name their corresponding vertices in the same order. So what that means here is if you were to write a congruency statement, let's say you had triangle ABC and triangle XYZ. Okay, and let's say I told you that angle A was congruent to angle X. Those would be corresponding angles. Angle B was congruent to Y, and angle C was congruent to Z. So those would be our corresponding angles there. It says when you name these figures, you must name their corresponding vertices in the same order. So if I was to name this first triangle, triangle ABC, I would have to name the second triangle in that same order. So A goes with X, B goes with Y, C goes with Z. So I would have to say triangle XYZ. So the order is important in those statements. And then if two shapes share a side, we call that a common side. For example, if you look at page 118 in your textbook, there are two polygons that share a side. They're connected along an edge. So we call that a common side. Now we also have a definition for congruent triangles and congruent polygons. They're basically the same definition, so I just combined it. So this says if two triangles or polygons are congruent, then their corresponding parts are congruent. And there's a phrase that you'll hear often is corresponding parts of congruent triangles are congruent. Or if you're dealing with a polygon, corresponding parts of congruent polygons are congruent. So if you have two congruent shapes, their corresponding parts or their matching parts must be congruent. So let's look at a few examples here. If you take a look at number 1, it says the triangles in figure 1, this should be figure 1, are congruent. So it's telling you that these two triangles are congruent. Name their corresponding angles and sides and write a congruency statement. Now on this one, there are markings for you, so you'll be able to follow along with those. Okay, and we're going to identify all our corresponding angles, sides, and then write a congruency statement just to practice identifying. So as far as corresponding angles go, you look for the angles that match up and are in the same position within the triangle and are congruent. So for example, angle A would have to correspond with angle D. So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Then for corresponding sides, well, our sides are segments. So if you take a look at these sides, side AB is marked as congruent to side DE, or I'm sorry, AB, I would have to name that DE, right, because A goes with D. Those are congruent, so those would be our corresponding segments there, so or corresponding sides. So we would say segment AB is congruent to segment DE. And then if you take a look here, AC goes with DF. So segment AC is congruent to segment DF. And then BC, so segment BC would go with segment EF. And then for a congruency statement, it's similar to what we did up above. You're going to show the two triangles are congruent and just make sure you use the proper order. So if I name this first one triangle ABC, I tend to go in alphabetical order. Put your congruent symbol, put your other triangle symbol. Remember, if you don't include the triangle symbol here, you're technically naming a plane. And since I said A, B, C, I'd have to say D, E, F for the other triangle. So triangle D, E, F. For number 2, it says, suppose you know that triangle FIN is congruent to triangle WEB. And it wants me to name a bunch of corresponding parts. We're actually going to practice this without a diagram. If you would like to draw a diagram, you're definitely welcome to, but I want to show you a way to do this without a picture, because you don't really have to have one if you have the congruency statement. So for number 2, suppose you know that triangle FIN is congruent to triangle WEB. Name 3 pairs of corresponding sides. Well, if you take a look at your two triangles here, FI and N are vertices, so that means FI is a side, segment IN is a side, and segment FN is a side. Then in WEB, segment WE is a side, segment EB is a side, and segment WB is a side. So you can actually not just look at where they match up in a diagram, but you can also look and see where the letters match up in your congruency statements. So, for example, these first 2 letters would have to be a segment, so I'm going to say that segment FI is congruent to segment WE. So that's like the first 2 letters with the first 2 letters. Then I could also say segment IN, that's the last 2 letters here. That would have to be a side, and that would go with the last 2 letters in the other part of the statement, which is segment EB. And then you can also go the first with the last. So that's segment FN is congruent to segment WB. Then for corresponding angles, if this is the name of your triangle, then angles F, I, and N, those are all your vertices, right? So just line those up. F would go with W, I would go with E, N would go with B. So angle F is congruent to angle W. Angle I is congruent to angle E. And angle N is congruent to angle B. Is it appropriate to say triangle NIF is congruent to triangle BEW? Well, this is asking you, did they match up their corresponding angles properly, right? Is this still in an okay order? Well, NIF is just taking your original statement and writing it backwards. And then BEW is also just taking your original statement and writing it backwards, so that's okay, because N goes with B, I goes with E, and F goes with W, just like it did originally. So this one is good to go. The second one says, is it appropriate to say triangle INF is congruent to triangle WEB? Well, this one's lining up I with E. So I with E. And if you look at your original statement, I still went with E. Okay, so that part's good. And then it lines up N with W. And though in your original statement goes with B. So there's an issue there. This second one would have to be EBW, not EWB. So this one is not an appropriate name. So we're going to say no, because our corresponding parts aren't written in the proper order. And then for number 3, it says the 2 triangles shown are congruent. I'm going to add the figure on yours. For me, I forgot to add it, so I'm just going to draw it real quick on the side here. Okay, so here's a sketch of the figure, and it says complete the following. Triangle AOB, triangle BABO would be congruent to what? And it's already telling us they're congruent. So if you can just identify the corresponding parts visually, angle A would have to go with angle C. B would have to go with D. And then O is a vertical angle here. That'd be angle DOC and BOA. That kind of aligns up with itself. So we would say triangle AOB is congruent to triangle CDO. Corresponding part, that would be congruent to angle C. So A with C. Segment AO would have to be congruent to segment CO. And the measure of BO would have to be equal to the measure of DO. Can you deduce that point O is the midpoint of any segments? Well, if you take a look at what I just labeled here, it would actually have to be the midpoint of both segment AC and DB because we have congruent parts on either side, so O must be the midpoint. So we're going to say yes, O is the midpoint of segment DB and segment AC because segment DO is congruent to segment BO and segment AO is congruent to segment CO. Then for part F, how can you deduce that segment DC is parallel to AB? Well, remember, parallel lines, we have to have a congruent angle relationship. And if you look, since these two triangles are congruent, angles C and A are going to have to be congruent to each other. And that gives us a pair of congruent alternate interior angles. So we would say that CD is parallel to AB because, and there's a few different ways you could say this. You could either say the alternate interior angle converse, right? Or you could say angle, I'm going to say because angle C is congruent to angle A, therefore, the alternate interior angle converse theorem applies. In other words, if you have congruent alternate interior angles, your lines must be parallel. And then for part G, suppose you know that segment DB is perpendicular to DC. Explain how you can deduce that DB is perpendicular to segment BA. Well, if segment DB is perpendicular to DC, you're going to have a right angle here. And if these two triangles are congruent, a right angle at D means that B will also be a right angle. And if you have a right angle, then these segments will have to be perpendicular as well. So we're going to say that if DB is perpendicular to DC, then angle D is 90 degrees. Therefore, angle B equals 90 degrees, making segment DB perpendicular to BA. And there's a few different ways you can phrase this. That's just one basic example. All right, you have a short book assignment. Please just let me know if you guys have any questions and have a great fall break.